In this video, I'll show you how to solve application problems containing exponential equations. The first question reads, use a table of values to sketch a graph showing the number of bacteria present for a 1-week experiment. So we have the following function, p of t is equal to 3 times 2 to the power of t over 2. What we'll do to start this question is to find out our p of t values for these x points that represent the number of days. And then we'll graph and solve some of these questions together. We also have another question, so make sure you watch the entire video. So to find out our y coordinates here, what we'll do is use our calculator, 3 bracket 2 to the power of 0 over 2, and this gives us 3. So at day 0, you start off with 3,000 bacteria. Let's continue. 4.24. Putting 2 into your calculator, you should get 6.3, or roughly that number. 9.13 for the next one. 13.23. 19.19. 27.78. And lastly, 40.26. And I'm going to plot this now. You should end up with something that looks like this. So there's the graph representing this data. The question is asking us, is the relationship linear, quadratic, or exponential? Give as many reasons as possible. So what we can do is take this number and divide it by that, take this number and divide it by that, take this number and divide it by that, and use the ratio of y's to see if it's consistent. So I'll do the first two, and I'll make the assumption that they are, if they are, very similar. 4.24 divided by 3 gives me approximately 1.41. So if the next one is around 1.41, I'll make the conclusion that it is exponential. 6.3 divided by 4.24 gives me approximately 1.48, which is a little bit off. So I'm just going to do one more to see if they are consistent. 9.13 divided by 6.3 gives me approximately 1.44. So I can conclude that since the ratios of y are very close to each other, this one being 1.41, then 1.48, then 1.44, we can assume that it is exponential. So one of the reasons is ratios of y values are similar. Another thing is that the function itself looks to have the same format as f of x is equal to b to the power of x, which is what an exponential function usually looks like. You have a base raised to a power that contains a variable. And lastly, the graph itself. The graph appears to be growing. It started off slow, and then it started to pick up on day 6 and 7. Graph appears to exponentially grow. Next question asks, what is the domain and range of this function? Explain the reason for the restrictions on t and p of t. So we'll start with the domain, and the domain is the possible days in our case. So from 0 to 7. And the way we write that down is we start off with a curly bracket. Time is represented here as x, so there's no need to differentiate with a t, which includes all real numbers between 0 and 7. And that is how you would write down the domain. And similarly for the range, we would start off with these curly brackets, and we won't use y here, we'll use p of t, which includes all real values between 3 and that last value we had was 40.26. So that answers questions A and B. Let's move on to 2. The growth of a particular bacteria can be modeled by the exponential equation p of t is equal to 3 bracket 2.1 to the power of t over 2, where p of t represents the number of bacteria in thousands and t represents the time in days. What was the initial population of the bacteria? Well, the initial population will occur at t is equal to 0. So if I set t is equal to 0, watch what happens. I don't even need to use a calculator here. Watch. 0 over 2 is 0. Anything to the power of 0 is 1. So 3 times 1 is equal to 3. So there were initially 3,000 bacteria because it's in thousands. So 3,000 initially. How many bacteria are present after 10 days? For this, you replace the t with a 10. So we have p of t at 10 days is equal to 3 times 2.1 to the power of 5. because 10 divided by 2 is 5. So we have 3 bracket 2.1 to the power of 5 gives us 122. Multiplying that by 1,000 gives us 122,000 amount of bacteria after 10 days. And so there you have it. That is how to solve two typical application problems containing exponential equations for students, namely in grades 10, 11, and maybe 12. If you found this tutorial helpful, please support our channel by subscribing or by liking this video. If you have any further questions, visit our website at studyforce.com. We're an online service for students seeking free homework help. See you soon.